So now we know that the second derivative is of the sign of the product x minus 2x plus 5, and that we can calculate using a sign chart, as we have done many times now. So the sign of the second derivative depends on the sign of the sign of x minus 2, and of x plus 5. X is going to change sign at 0. It is positive if x is greater than 0, negative otherwise. X minus 2 is positive if x is greater than 2, so on the right of 2, and negative otherwise. X plus 5 is positive if x is greater than negative 5, and negative otherwise. On the interval from negative infinity to negative 5, all three factors are negative, so the second derivative, which is of the sign of the product, is negative. From negative 5 to 0, I have two negative factors, so the product is positive. From 0 to 2, there's only one negative factor, so I get a negative product. And from 2 to infinity, I have three positive factors, so the product is positive. Now I can interpret in terms of concavity. Whenever the second derivative is negative, the function is concave down. Whenever the second derivative is positive, the function is concave up. So this is the concavity. Recall that we had found the coordinates of a local maximum and a local minimum, and I can enter these values in my chart, as well as the coordinate of the inflection point. Note that there are three places where the concavity changes: at negative 5, at 0, and at 2. However, at negative 5 and at 2, there is no point on the graph corresponding to these x values. We have vertical asymptotes. So the only inflection point is at x equals 0, and when x equals 0, I plug this value of x in the function f, I get 0 as well. So 0, 0 is an inflection point and is a point on the graph of the function. So I'm going to enter these values in my chart, the y coordinate for the local maximum, for the local minimum, and for the inflection point. Now we have gathered all the information in that chart and we're ready to sketch the graph. When we sketch the graph, the first thing we need to do is draw the asymptotes. In this case, we have two vertical asymptotes, x equal 2 and x equal negative 5, and we also have a slant asymptote y equal x minus 3, which is this line. Then we have to plot the important points, which are local extrema and inflection points. In our case, we have a local maximum at negative 3 minus root 39, and its y value is approximately negative 16.6. At this point, we have an horizontal tangent. We have a local minimum at negative 3 plus root 39, and its y coordinate is approximately 3.3. Again, we have an horizontal tangent at this point, and so do we at the inflection point at 0, 0, because we have seen that the derivative takes a value 0 at 0. Now we're going to follow the information we have on increase and decrease and concavity in the chart. If I look at the first interval from negative infinity to negative root 3 minus root 39, the function is increasing, concave down, and approaches the line y equal x minus 3 when x goes to negative infinity. So we get a smooth arc that approaches the asymptote, is increasing and concave down towards my local maximum. Then, in the second interval from negative 3 minus root 39 to negative 5, function is still concave down, but now is decreasing. And x equal negative 5 is a vertical asymptote, so I get this type of behavior, where the graph of the function is going to approach the vertical asymptote. It is concave down, decreasing. On the other side of the vertical asymptote, on the interval negative 5, 0, the function is decreasing, concave up, approaching x equal negative 5, so coming from positive infinity on the right of x equal negative 5, and is going to come to this inflection point with an horizontal tangent. So I get a piece of graph like that, decreasing, concave up, with this horizontal tangent at the inflection point. On the interval 0, 2, the function is still decreasing, but now the concavity changed to concave down. And the graph is going to approach the vertical line x equal 2 because it's a vertical asymptote. Again, I have this horizontal tangent at x equals 0. So, decreasing concave down, starting with an horizontal tangent, I get something like that. Moving to the other side of the vertical asymptote, the function is decreasing but now concave up, again with a vertical asymptote at x equal 2. And I have a piece of graph like that, decreasing, concave up, approaching this vertical asymptote, and with an horizontal tangent at my local minimum. Finally, from negative 3 plus root 39 to infinity, the function is increasing, concave up, approaching the line y equal x minus 3. So I get something that looks like that. So this is a more complicated example, but at least we could go through. So now we've seen many examples, and it is time for you to turn to homework before you do the sample quiz and then the quiz.